Here we have a SAT math problem. Okay, let's go to the question. In the figure above, three identical circles with radius of 5 are tangent to one another. If lines L and M are parallel and tangent to the circles, what is the value of h, the distance between the two lines? Okay, in my first step, what I'm going to do is I'm going to connect the centers of all the three circles with line segments. Okay, let me do it. Here I have connected the centers of all the three circles with line segments. Okay, here we know that this is the radius of the circle we have here, and all the three circles are identical circles with radius of 5 unit. So the length of this part is 5 and the length of this part is 5. Then the length of this side of the triangle is 10, and the same thing we have over here. There is this radius of 5 units, and here we have radius of 5, and here we have 5, and here we have 5. Actually, here we get an equilateral triangle with the side length of 10 units. Okay, now let me draw an altitude to this triangle over here. There is a vertical line segment over here. Since this vertical line segment is altitude for this triangle, so it has to intersect the side of the triangle over here at right angle. And also, since it's an equal triangle, each interior angle will measure 60 degrees. Here 60 degrees, here 60 degrees. In an equilateral triangle, always the altitude will bisect this interior angle over here. That means it will divide this angle into two equal parts. Then the measure of each part over here at this interior angle is 30 degrees. So here we have 30 degrees, and here we have 30 degrees, and the measure of this interior angle is 60 degrees, and here we have a right angle. Now let's consider the right triangle ABC over here. It is a special right triangle. That is a 30, 60, 90 special right triangle. In a special right triangle, the side which is opposite to the smallest angle, 30 degrees, is considered to be the shortest leg. So here this side BC is opposite to the smallest angle measured 30 degrees. So this is the shortest leg of this special right triangle. Usually we consider x as the length of the shortest leg. Then the length of the next longer leg, that is the side which is opposite to 60-degree angle measure, has to be x times square root of 3. That is, we have to multiply the length of the shortest leg by square root of 3 to get the length of the next longer leg. And the length of the hypotenuse, that is the side which is opposite to the right angle, has to be 2 times the length of the shortest leg, that is 2x. But here already we know the length of the shortest leg BC, that is 5. So instead of x we have 5. So here instead of x times square root of 3 for this altitude, what we can write is 5 times square root of 3. Okay, here I got the length of this line segment AB, that is 5 times square root of 3. What is the length of this part over here? Actually, this line segment I have drawn over here represents a radius. So we know that the radius of each circle is 5. The length of this part is 5. Okay, here we have the length of this part, that is 5. And we have the length of this part, that is 5 times square root of 3. And what is the length of this part? This part represents a radius. Again, this length is 5 over here. Now, to get the distance between the two lines L and M, we have to add this 5 times square root of 3 and this 5. So the required distance equals to 5 positive 5 times square root of 3 positive 5. We can write this 5 times square root of 3 at first, and when I combine this positive 5 and positive 5, I am getting positive 10. Okay, here I got the distance between the two parallel lines L and M, that is 5 times square root of 3 positive 10. We find this stuff in answer choice C. The correct answer choice for this question is C.